Hello, I'm your instructor for today's lesson. My name's Kevin Large and we're going to go through some basic switch and basic router configuration. Specifically, what we're going to look at for the basic switch configuration is the configuration of a host name, VLANs, virtual local area networks. We're going to associate switch ports with the VLANs. We're going to configure spanning tree port fast on the switch ports. We're going to create trunk links on the switch. The trunk link carries all the VLANs unless you tell it not to, whereas an access port carries only one VLAN, or is associated with only one VLAN. For the basic router configuration, we're going to again put a host name on. We're going to create sub-interfaces. The sub-interfaces will function as 802.1 trunk encapsulation sub-interfaces, so they can actually see the tagged frames going in and out. We're going to create a DHCP pool. In fact, we're going to create 3 DHCP pools, one for each VLAN, and we'll create some DHCP excluded addresses. A little homage to the Empire. And we're going to use Packet Tracer, Cisco Packet Tracer, to do this job. So here we have Packet Tracer, and I'm going to select the first device, which will be a Cisco 2811 series router. We're also going to have some layer 2 switches, which will be Cisco 2950 24 switches, and I will put 2 of those on. Okay, and we will have 3 end stations, 3 PCs, just for testing purposes. So we're going to put 3 generic PCs, 2 on that switch, and 1 over here on this switch. Okay. Now we'll need to wire these up, and we need to use the correct cables. So generally speaking, the way you can do this is, if it's not the same device on each end of the cable, we use a straight through. If it's the same device on each end of the cable, we use a crossover. There is one exception to that. If you wire a PC directly into a router, in that particular case you would think, well, they're different devices, so it's a straight through, but it's not. It's actually a crossover in that case. Because normally you wouldn't wire a PC directly into a router, you would go via a switch. If you take the switch out, the cable needs to do the crossing. Okay, so let's just do the crossovers first. So we'll go switch to switch, fast Ethernet 24 to fast Ethernet 24. And we'll go from switch to router, fast Ethernet 23 to fast Ethernet 00. Okay, and now we'll put the PCs on. So again, this will be a straight through, fast Ethernet 0. We'll go into switch port 1, fast Ethernet 0, and into switch port 10. And on this one, fast Ethernet 0 into switch port 10. What we'll do, we'll create 2 VLANs and 2 DHCP pools. Okay, let's tidy the screen up just a little bit. Okay, now we need to do some IP addressing. So we'll use a master IP address of 200.1.1.0 with a /24 mask. And that will be our master address, so we'll subnet everything off of that address. Now let's see, we'll have 50 PCs, 50 hosts in this particular VLAN, and this can be VLAN 10. And we'll have 25 hosts. VLAN 20. Okay, let's tidy that up a little bit. 50 hosts in VLAN 10, 25 hosts in VLAN 20, and we'll make this PC here also a member of VLAN 20. Okay. So if we're going to do that, we need to do a little bit of subnetting now. So if we want 50 hosts over here, that will need to start with the main network. So that will be 200.1.1.0. Now 50 hosts plus the network and broadcast is 52, plus the default gateway address is 53. So we need a binary number close to 53 but bigger than it. Well, that will be 64. How do we get 64? How many bits do we need to borrow? 2 to the power of 6 would be 64. So we've got 2, 4, 8, 16, 32, 6. 2 to the power of 6, 32 minus 6 gives us 26. Okay, so that's 200.1.1.0/26. That subnet starts at 0, it's 64 big, so that will become 200.1.1.64. If it starts at 0 and it's 64 big, the next subnet up will be 200.1.1.64. That needs 25 hosts, plus the network and broadcast, 27, plus the default gateway, 28. Nearest binary number to that will be 32. 2 to the power of 5 is 32. 32 minus 5 is 27. Okay, so that will be 200.1.1.0 64 network /27. Of course, this PC will also be in that particular network. Right, just tidy the screen up a little bit. So what are our default gateways going to be? Well, the default gateways will be on the sub interfaces on the router. So let's use the highest IP address that's usable on these subnets. So on this 200.1.1.0 subnet, we've got 200.1.1.64 being the next network up. So the broadcast for the 200.1.1.0 subnet will be 200.1.1.63, one less than the next network up. So the default gateway will be 200.1.1.62. Okay, so we'll have 200.1.1.62 as our default gateway for that network. This network here, that is 32 big. So if it starts at 64 and it's 32 big, 64 and 32 is 96. 96 would be the next network up. So 95 would be the broadcast address. So 94 would be the default gateway. 200.1.1.94. Okay. And of course that will be a /27. And this one will be a /26. And they will both actually be on this cable and on this interface, which is why we need to use sub-interfaces. Okay, let's quickly get into some configuration now. First things first, we'll go into a switch. Now you can see why I split the screen in half. Okay, so there's our switch, 24 port, layer 2 switch. Bring up the command line interface. And we'll type enable, which we can shorten to ENA. And we'll give the switch a name. So we'll go into configuration terminal mode, shorten to conf-t. And we'll type hostname. I'll type host and hit tab to finish the command. SW1. The switch now has a hostname of SW1. I will type exit. And I will type show IP interface brief, just to see which ports have cables in. Port 1 has a cable in. Port 10 has a cable in. That's this PC and this PC. Hit the spacebar to go down a page at a time. Port 024, that also has a cable in, which is our trunk link between the two switches. Okay. Let's see what VLANs we've got. Show VLAN brief. Okay, so we've got the default VLANs on the switch. 1, 1002, 1003, 1004, 1005. They're all active, but all of the ports are in the default VLAN 1, which is the way it should be. When the switch is first powered up with no configuration, all the ports should be in VLAN 1. What we now need to do is we need to create our VLANs. And these VLANs will be created from global configuration mode, conf-t, configure terminal, VLAN 10, drops us into VLAN configuration mode. We'll name this VLAN sales and exit. I'll use the up arrow to save typing. Up arrow 3 times, VLAN 20, up arrow, up arrow, up arrow, name, I don't know, let's call it accounts, and up arrow 3 times to exit. Probably would have been quicker to type exit there. Okay, I'm going to hit Control Z. Control Z jumps you right back from however deep you are in configuration mode. It'll jump you right back to privilege mode. Okay, and then I'll use the up arrow to do a show VLAN brief. Now we can see that we've got our two VLANs, sales and accounts, and they're both active. All we need to do now is put the switch ports in. So we'll put ports 1 to 9 in VLAN 10. So, global configuration mode, Conf T, interface, I'll just type INT and hit tab, R for range, hit tab, FA for fast Ethernet, hit tab. The tab will save you so much time. 0/1 space hyphen space 9. It's very important that you type it in like that because that's the correct way of doing it. 0/1 space hyphen space 9. Okay, now we're in interface range. We're actually configuring all of those interfaces at once. I'm going to type switch port mode access to make it an access switch port. An access switch port can only be in the one VLAN. Well, actually one data VLAN and one voice VLAN, but we won't go there. It's not a trunk link. A trunk link would normally carry all the VLANs. And then we'll type switch port access VLAN 10. Okay, while we're here, we're going to put spanning tree port fast on. We get a little warning popping up saying be very careful with this command. Spanning tree is designed to detect layer 2 loops, bridging loops, because at layer 2 you have no time to live field. The time to live field, the TTL, is at layer 3. It's in an IP packet. That will stop a packet from going round and round forever. But there is no TTL field at layer 2, so potentially speaking a packet could go round and round in a loop forever. So we have spanning tree protocol designed to block loops. You like to have redundancy in the network, but if you have redundant links between switches and there's enough to configure it to create a loop, then you can get a loop and the frame will go round and round that loop, broadcasting, coming out of all of the ports, and totally destroy your network. Okay, so what we normally use is we have spanning tree to detect those loops. But in this particular case, these ports are all going to PCs, so there shouldn't be any chance of a loop. So rather than have the ports down for 50 seconds while spanning tree does its loop detection and finally brings it up, we can put spanning tree port fast on, and that will bring it up very, very quickly indeed. Very useful if you're running DHCP, which we will be shortly. Okay, so let's exit that to drop us back into normal configuration mode. I will use the up arrow again to find the interfaces, and now we'll move back and we'll say interface range fast Ethernet 0/10 space hyphen space. We'll go up to 20 and use our up arrow again. Switch port mode access, switch port access VLAN 20. Great. Okay, so what we've done is we've created the VLANs, we've named the VLANs, we've put the switch ports into the VLANs on the one switch. What we need to do now is we need to make sure that fast Ethernet 024, which is the link between the switches, is configured as a trunk link. So back to configuration mode, interface fast Ethernet 024. Now if switch port mode access made it an access link, I'm sure you can guess that switch port mode trunk will make it a trunk link. Okay, that is now a trunk link. And for the moment I think that's everything we need to do on this switch, so I'm going to do a Control Z, and I could type copy run start, copy running config, startup config like that to save the configuration, Anything in square brackets is the default, so I just hit enter. Or I could use the old command, WR, which is short for write terminal, which of course is a lot quicker to type. Okay, we'll now move into the second switch, see what's happening over there. Okie dokie, let's see what we've got going on here. So, first thing to do, go into configuration mode, conf t, and give the switch a host name. SW2. Very important, it's so easy to end up putting the wrong configuration on the wrong device if everything's called switch and router. Okay, excellent. Now I'm going to hit Control Z just for a moment, and I'm going to do a show VLAN brief. Notice how I abbreviated show to SH. You can abbreviate any command as long as you don't abbreviate the command so much that it's ambiguous. More than one command begins with that character. If you do that, what you will get is you'll get something that looks like this. If I type E and hit enter, it doesn't know which command I want. If I type E and question mark, it's actually telling me that there are 3 commands that begin with E, so it's an ambiguous command. Okay. Now I can see that we do not have any VLANs on here. Let's try something. I'm going to go into the port that's connected to the other switch with a configure terminal and interface fast Ethernet 024. This is going to be the trunk link connecting to the other switch. I'm going to type switch port mode trunk. While I'm here, actually, I'm just going to go back one. I'm going to go into interface fast Ethernet 023, which is the link up to the router, and make that a trunk link as well. I can use my up arrow to save commands. I'm going to do a Control Z and a WR just to make sure I save the configuration. I'm going to use the up arrow now to find show VLAN brief. Okay, we're good to go. And I'm going to create the VLANs on this switch. Okay, so configure terminal, VLAN 10. Now what did I call that VLAN? Sales, wasn't it? Sales. And exit. Up arrow, VLAN 20, name, accounts. And I'm going to do a Control Z and a WR. It's always good to save your configuration, just in case you get a power cut. And we'll have a little look. Show VLAN brief. We now have our VLANs, but notice we don't have any ports in those VLANs. Now I'm not sure which port I put that PC in, but I can check from the command line. Show IP interface brief, shortened to show IP int brief, or show IP int br. Okay. So look, fast Ethernet 010. That's an up and up. Well, if it's an up and up, it's got a cable with a PC on the end of it in this case, so that's the port I plugged it into. Okay, fast Ethernet 024 is also up and up. That's my trunk link to the other switch. So now let's put some ports in. Let's do exactly what we did with the last one. So conf t, interface, range, fast Ethernet, good use of the tab there, 01-9, switch port mode access, switch port access VLAN. Oh, I love that tab. 10. Exit. Up arrow. Let's select ports 010 to 020, and we'll do the same thing again. So we'll do a switch port mode access and a switch port access VLAN 20, and we'll do a Control Z. The WR, just to make sure we've saved everything. I'll use the up arrow again to find show VLAN brief, and that's looking good. In fact, that's looking really, really good. Okay. Now, interestingly, notice that Fast Ethernet 024 does not show up in that list. Why does Fast Ethernet 024 not show up in that list? Because it's not associated with a specific VLAN. Fast Ethernet 024 is the trunk link. And because it's the trunk link, it's associated with all the VLANs by default. Well, all the VLANs can flow through it by default. So it doesn't show up in the list. Fast Ethernet 023 is also a trunk link, and it does show up in the list, but that's only because the link is down. If you look at the diagram on the other side, you can see the link is currently down because the router on the other end is down. So until this link comes up, and the switch realizes it's a trunk link, we're still seeing Fast Ethernet 023. If we want to know some information about the trunk links, we can say show interface trunk. And you can see, there we go, Fast Ethernet 024. It's on, it's a trunk link, it's using the IEEE, Institute of Electrical and Electronic Engineers, 802.1q encapsulation. And trunk, in this particular case, ports allowed on the trunk, all of them. Ports that are actually in the trunk, the default one, and the two VLANs that we created. So VLAN 1, VLAN 10, VLAN 20. Okay, so that's looking good. Everything's done on the switches, I do believe. So we can do a write on there just to make sure and move on to the router. Okay, now things get a little bit more interesting. We're moving on to the layer 3 device. You notice by default this port is not enabled on the router. It's actually in a shutdown state. There's a very good reason for that. If you break into a router, then you're going to cause all kinds of havoc on a network. In many ways it's one of the most important devices on the entire network, so it's quite secure by default. Okay, this router is known as router, so the first thing to do is to give it a good host name. ENA, short for enable. Conft, configure terminal. Host name R1. Not very imaginative, I know, but it'll do the job. Okay, now we're going to go into the interface. Fast Ethernet 0/0, the one pointing down to the switch. And just to make sure, we're going to type no IP address, because we do not want an IP address on the physical interface. And then we'll do a no shutdown to switch the interface on. And you can see the light's gone green. The light is green on this end. It's orange on the other end because of spanning tree protocol. So we did not switch spanning tree protocol to port fast on this end, so it will take a long time for this particular port to go live. 50 seconds, in fact. But that's a good thing because it's a trunk link, and you should be very, very careful with spanning tree port fast. Access links, yes. Trunk links, ooh, very careful with that. Okay, now we now have a green light. The link is up, both ends. Okay, we're now going to do an exit. We do not need an IP address on the physical interface because we're going to create two sub-interfaces, and these will have the IP addresses. There'll be the IP addresses 200.1.162 and 200.1.1.94. They will be our default gateways. Okay, here we go. So I'm already in configuration mode. Interface Fast Ethernet 0/0.10. Now I could use any number I like. You can create literally millions of sub-interfaces. Well, the number goes up to millions. I wouldn't create millions on one particular router, of course, because that would be crazy. But you can create a considerable number of sub-interfaces on a router, but the designation number can be absolutely enormous. In this particular case, because this is going to be for VLAN 10, I'll create the sub-interface as Fast Ethernet 0/0.10. Makes sense, ties in with VLAN 10. Okay. Now, if I try to put an IP address on the interface, I'm going to have a problem. I'll show you exactly what I mean. IP address 200.1.1. What do I want? 62. Okay, highest IP address on the VLAN 10 subnet, followed by a /26 mask, which is 255.255.255. There's 8 bits plus 8 bits plus 8 bits. There's 24 bits there, plus the first 2 bits in the 4th octet, which is the 128-bit and the 64-bit, to give us 192. So we've got 8, 16, 24, and those 2 bits there, 192. There you go. That will happen because currently we have not set the encapsulation up on this subinterface. So let's do that. Encapsulation .1q followed by the VLAN tag that is going to be expected on this particular subinterface. This is subinterface 10, so that's VLAN tag 10. Now if I hit the up arrow and put that IP address back in, no problem whatsoever. Okay, we don't need to do a no shut because the subinterface should already be up because the main interface is up. I'm going to type exit, and very quickly we'll do the other interface. So interface fast Ethernet 0/0 20. These are not real interfaces, of course. These are logical interfaces. They're sub-interfaces. You can't stick a cable in it. The cable goes in the physical interface, the real interface, fast Ethernet 0/0. But these are logical sub-interfaces. Okay, another sub-interface created. Let's do it in the right order this time. So encapsulation .1q 20, and let's put the IP address for this default gateway, which will be 200.1.194, the highest IP address on the 200.1.164 subnet. Okay, I will go to the end of that end of that line. And what is a /27 mask? Well, that will be 255.255.255 is 24, plus the first 3 bits in the 4th octet. That will be the 128-bit, the 64-bit, and the 32-bit. 128, 64, and 32 added together will give us 224. Okay, looking good. Control Z, WR. If I now do a show IP interface brief, you will notice I have a fast Ethernet interface, the physical interface. No IP address is assigned, but it's up and up. Up at layer 1, up at layer 2. We can see the correct protocol. Fast Ethernet 0010 does have an IP address on it, up and up, and so does Fast Ethernet 0020, which are, of course, these are our sub-interfaces, and these are the default gateways for the PCs in their respective VLANs. Okay, now all we need to do now is set up DHCP. Let's just try something first. Ready? Show IP route. If we do a show IP route, we can see that there are 2 networks. The 200.110/26 network, which is directly connected to the router out of the Fast Ethernet 00.10 subinterface. This is the VLAN over here, VLAN 10. And we have another network, 200.164/27, directly connected, this time out of Fast Ethernet 00.20, the other subinterface. And this is the VLAN 20 with the 200.164/27 subnet on it. And of course, so is this one. They are both in VLAN 20, even though they are on different switches. So we need to create how many DHCP pools? Well, there are 2 subnets, and here are their network addresses, so we need 2 DHCP pools. And here we go. Configure terminal, IP DHCP pool. I will call this pool VLAN 10. Okay. And we'll create a network, and this defines the addresses that can be given out. They can be only addresses in this network. 200.1.1.0, and a subnet mask, which has to be in longhand, so that will be 255.255.255.192. Excellent. Put a default router on. Default router will give out the default gateway. This command here, the network command, will give out the IP address and the subnet mask. The default router command will give out the default gateway, which for the VLAN 10 subnet is 200.1.1.62. 200.1.1.62. Excellent, job done. Exit that. Definitely going to use the up arrow for this one. Okay, IP DHCP Pool VLAN 20. And we want the VLAN 20 subnet, which will be a 224 subnet mask and a network address of 200.1.1.64. Excellent. Now our default router will be 200.1.1.94, and we're done. There is only one thing to do now. Let's put our excluded addresses in. We'll exclude the first 5 addresses from each pool. This is unusual. Conft. You would expect it to be done under the IP pool, the IP DHCP pool, but it's not. It's done under global configuration. IP DHCP excluded address. How good is that tab? I just typed EX and hit tab. Okay, so we'll exclude the first set of addresses, which will be from 200.1.1.1. We said the first 5, didn't we? So we'll go up to 200.1.1.5. Okay, so the first address that should be handed out by this DHCP pool would be 200.1.1.6, because the first 5 will be excluded from being handed out. Why would you do this? Well, possibly your servers are going to have static addresses in that particular network, so you don't want to hand out IP addresses that are already configured statically on the servers. Okay, and we'll do the one for the other excluded range, which will be, let's go back to the first one because it'll be easier that way. 200.1.1.65 will be the first address on the 64 subnet, and that will go up to 200.1.1.70. There's our 5 addresses to be excluded. So the first address in the VLAN 20 subnet should be 200.1.1.71, and the other one will be 200.1.1.72, and this should be 200.1.1.6. Time to check. I'll do a Control Z and a WR. I'll do a show IP DHCP bindings. Actually, I think it's just binding. There we go. So currently, no DHCP IP addresses have been handed out by the router. That is not surprising. The PCs haven't asked for any yet. Next job, into the PCs. We'll do VLAN 10 first. And we'll move this over here so as we can see things actually happening. We go to the desktop, the command prompt. I'm going to type ipconfig just to see what IP address we have. And we have no IP addresses. Okay. I'm going to click on the IP configuration tab and go to DHCP. And yes, it did exactly what we hoped it would. It's given us the first address that's allowed in the first pool, and that address is 200.1.1.6. It's given us the correct subnet mask 255.255.255.192/26 and the correct default gateway address, which is the address on subnet for VLAN, on the sub interface for VLAN 10. Fantastic. Let's have a look at the ipconfig command one more time, and that's looking pretty good. Let's move that across a little bit so as we can see what's happening easier. Ideal. Let's run the show IP DHCP binding, and we can see that the IP address has indeed been given out by the router. There's our IP address, and there's the MAC address of the device it gave it out to. How can we see that on the PC? ipconfig /all, and there we go. Let's have a little look. Physical address 00D0 3AC2, precisely the same address we've got over here. Excellent. Okay, so that works okay. Let's try VLAN 20. desktop, command prompt, ipconfig /all, might as well do the big one. Okay, no IP address. Now what should this get? This should get 71. And it does, 200.1.1.71 with the /27 mask and the default gateway address of 200.1.1.94. Absolutely fantastic. Okay, let's double check our IP addressing. ipconfig /all 200.1.1.71. Fantastic. And let's try this one as well, just to finish it off. Now this is also in the VLAN 20, even though it's on a different switch. ipconfig /all, and here we go. Should get 72, and it does. Fantastic. Excellent. Look at that. Right. Show IP DHCP bindings. 1.6 to VLAN 10, 1.71 and 1.72 to VLAN 20. Let's see if the PC can ping from VLAN 20, which is where this one is in, to VLAN 10, the other PC, 200.1.1.6. So I'm now pinging from a PC in VLAN 20 to a PC in VLAN 10. Now let's see if it works. And there's a slight delay there. This is where you cross your fingers. And yes, it works. Now interestingly, look at that. The first packet timed out. Why did that first packet time out? The other three got through. The reason for that is ARP, the Address Resolution Protocol. If I type ARP -A, you can see that the very first thing this PC had to do was go and find the IP address of the default gateway in order to get to a remote subnet. VLAN 20 is a remote subnet. He has to go through the router to get to it. So the first thing this PC had to do was contact the default gateway, the router, and it had to get the default gateway's MAC address. So it would have used the ARP, the Address Resolution Protocol, in order to get the default gateway's MAC address. If I run those pings again, we should see all four come through, because it's already got the MAC address. Okay, layer 2 Ethernet segments, they use MAC addresses for communication, so the very first thing that had to happen, we had to get that MAC address, so we used the Address Resolution Protocol to do that. Fantastic. Okay, so what have we done? We've gone on the switch, we've given it a host name, we've created VLANs, we've named the VLANs, we've put switch ports into the VLANs, we've created a trunk link between the switches, which carries all the active VLANs, in this case VLAN 1, the default, VLAN 10 and VLAN 20. We created a trunk link up to the router, we created sub-interfaces on the routers, and on those sub-interfaces we set the encapsulation to the correct VLAN number, so it expects the correctly tagged VLAN on each sub-interface, and we've put the IP address for each of the VLAN's subnets. VLAN 10, 200.1.1.0 subnet. The highest usable IP address is 200.1.1.62, so that's their default gateway. VLAN 20, the 200.1.1.64 subnet. The highest IP address is 200.1.1.94, so that's the default gateway. And there you go. We have configured what's known as router on a stick. I hope you found that useful. And that's me signing off from this configuration video. Don't forget to keep an eye on the website, keep an eye on YouTube, Remote Training Solutions, and I'll see if I can put some more videos up to go through some more concepts in the wonderful world of Cisco. Yes, there's nothing else that beats a bit of Cisco configuration. Thank you very much indeed.